Today I'll be talking about Darwinism and evolution. Now, evolution was there before Darwin, so it wasn't Darwin who discovered evolution. Darwinism is the version of evolution that Darwin was able to postulate. And evolution, as we know it today, carries a lot of the postulates of Darwin, but obviously we know more than Darwin about a number of things, including, for example, aspects of inheritance. So let's go first and talk about the time before Darwin, or at least when Darwin appeared in this world, there were various mysteries in the 19th century. In the middle of the 19th century, people were discovering more and more fossils. For people who don't know what a fossil is, it's something that you find occasionally when you break a rock, and then you find something there that looks like an organism. And this is not the organism, it's not even the remains of the organism, it's just traces and, in a way, prints of what the organism looked like. So fossils indicate that there were organisms there in the rocks, and they're debating at that time what sort of, what could they explain, how could they explain, for example, what fossils are. Now, some people call them jokes of nature. Some, well, prefer to consider them to be ways by which Satan is actually luring us from our faith to lure us into believing that there was no creation, it was just something that was there before creation. And some people suggested it might actually be God's test of our faith. So if we fail the test, then God knows what will happen to us. And then there were all sort of myths, like people thought of these fossils as mythical organisms, like dragons and so on, especially some of them would look like dragons. And some of them were probably turned into stone by some sacred people, saints, whatever. And there was the notion that these fossils are nothing but the traces of creatures that existed, and they have gone extinct. Other mysteries that naturalists were debating at that time were things such as why so much variability and why so much diversity. Now, first, why there were so many different species? Now, at that time, they didn't even have a clue of how many species we have. Now, today, we consider that maybe the Earth contains maybe something like 100 million species. At that time, they thought there were too many species, and they couldn't explain why. And the other aspect is why, within any particular species, you have so much variation. And we could see this in all sorts of organisms, including ourselves. We have quite a lot of variation in just one humankind. Now, the other aspect there that was not so easy to debate is really whether species were fixed or they changed over time. Because if you consider that the species were fixed, that means that's the way they were created by God. If you think that they change over time, that means you come to the idea that species actually evolve. Now, there were evidence from the fossils that some species looked something in earlier times, and then they looked something different in later fossils, and looked even different today. Now, here comes Charles Darwin in the middle of the 18th century, in effect, the 19th century. And well, he was born to a middle-class Anglican father who was a successful doctor. And like many doctors, they would like their sons to become doctors also. And he tried. So at 16, he started to study at Edinburgh University, study medicine. And then later, he found out that that's not really the sort of thing that he would like. There are different stories about this. One of them was that he hated the surgical procedure at that time when there was no anesthetic. And some people said that he had his heart elsewhere. Now, in 1827, he transferred to study something also very unlikely, and that's theology, in the hope that he would become a minister in the Church of England. This was a thing that some aristocracy considered to be two options there, either to become a doctor or an officer or minister in the church. On the whole, he wasn't such a brilliant student as far as people could assess, and so he was more interested in other things such as hunting and natural history, and his father was quite dissatisfied with him, and once He wrote to him, you care for nothing but shooting dogs and rat catching, and you will be a disgrace to yourself and all your family. I will come to this quote later on when we see what Darwin has actually achieved. So, when in the middle of all this uncertainty about his future, eventually he got this chance to go on a voyage from 1831 to 1836. It's thought that maybe there was a sort of wasta involved. But anyway, he got on the ship as the ship's naturalist. It was one of those positions that ships usually that went on expeditions would have a naturalist on board. And see, he was the naturalist on board. Now, for him, it was a big change to go from England all the way to Brazil. And, you know, in this Amazonian forest, tropical forest, he collected all sorts of organisms there. And he was really amazed by the huge diversity that was nothing to compare with England. And the tip of South America, he met some Indians there who were actually living in very harsh conditions. And these are very cold regions there, and they were just barely dressed, and they managed to survive against all the odds in very hostile environment. He also had an experience in Chile with an earthquake, and that part of the world, as we hear, is quite known for earthquakes. And so the earthquake that he experienced raised the level of the land 2 meters, and he had this first-hand experience of what nature could show, what sort of changes might actually occur, and geologically. And just to point out that at that time, Darwin was quite often interested in geology more than in biology. He was a naturalist, but he was a geologist more than a biologist. Now, he actually changed to become a biologist when they visited the archipelago of the Galapagos. These are several islands there, and volcanic islands, and they had different sort of histories. There are big islands, small islands, depending on how old the volcano on the island is. And so he was able to also witness some geological phenomena there. And one of the things that he noticed were these unusual collection of animals, organisms generally, and animals in particular, that were not found anywhere else, even in the nearest South America. And he actually collected quite a lot of these organisms, and later on they would be important in formulating some of his ideas. But while he was there, as he wrote afterwards, that while he was in the Galapagos, he felt that he was brought within reach of that great fact, that mystery of mysteries. And that mystery of mysteries he was talking about was actually the realization of how life not began, but how species appeared on Earth, how organisms appeared on Earth, and how they appear in various places, including on islands like this one. Now, after coming back, after 5 years going back to England, there he settled, and he survived on his father's money, and he didn't have really to work all his life, and that actually gave him plenty of time to do all sorts of studies. He actually published quite a lot of work on some of the things that he collected in different parts of the world. And he wrote several books on these, and some major monographs that he would be known for them, even if he hadn't actually got into the idea of evolution. Now, he didn't talk about evolution during that time, except to his close friends. And so they were aware of some of his ideas. He didn't dare to discuss these more publicly. He didn't dare to publish on them. And one day, he got a letter from Alfred Wallace, who had actually come from the other end of the social divide, where he was not such a well-off person, and he had to really work hard to collect organisms from here and there around the world, and then bring them to England and sell them to museums and so on. But while in the middle of a fever in the Far East, he comes up with this idea of natural selection. And so he wrote to Darwin. Actually, when he wrote to Darwin, he was getting Darwin's ideas about Darwin's remarks on something that he wants to publish. And so he was trying to write a paper, and he asked Darwin to make some comments on it. And so, anyway, this outlines some mechanism of evolution that was similar to Darwin's own. And so with his friends, they decided that you couldn't just leave it to somebody else. And so after so many years of thinking about an idea of this sort, and so eventually they decided to be fair and present the idea jointly in a meeting of the Linnaean Society. which still exists today. It's a Linnaean site in Britain from Linnaeus, the father of taxonomy. Anyway, so they presented 2 papers about the same topic in that meeting, but during that meeting, nobody took much note of what they talked about, but the idea they were presenting was natural selection. And I will be saying more about natural selection later. Now, in 1859, he decided eventually that he should publish his ideas, and so he wrote this huge book that is thought to be 1 volume of a big series of books that he wanted to write. And so he put things together and he published his major work, one he's known most for, and that's The Origin of Species, by means of natural selection or the preservation of favored races in the struggle for life. This is the way these books at that time would have a long title like this one. Now, he wasn't hoping that it will sell really, but actually, surprisingly, it sold out in 1 day. And then he had to publish several editions later. Now, in all these editions, he never mentioned the word evolve or evolution, except in the last paragraph of the book. But he wasn't actually using the term evolution to talk about evolution as we know today. He actually used something more elaborate, which was descent with modification. But in the 6th edition, he had to really accept the fact that a lot of people refer to this phenomena as being evolution. Now, the ideas of Darwin were not all his own, and so there were some postulates there that were there before him, but he was able to produce a lot of evidence for each one of these. So the first one, which was accepted by a lot before, was that species were not constant. They changed over time. The change was gradual, and that was something that, for example, Lamarck before him was talking about, that the species changed very slowly over time. And there was also the fact that, in the same way that, organisms breed and they reproduce, and so species also could lead to different sorts of species. And so branching will occur in the same way like you have a family tree of some sort. And the idea that was Darwin's own, actually, to be fair, it was the idea of Darwin and Wallace, that was the idea of natural selection, that the mechanism of evolution that people were not able to really formulate, that mechanism was the process of natural selection. So let's start with the first postulate there, and that's really the non-constancy of species, that species change. Now, that's not new, actually. It's quite old, and at least the Greek and Roman philosophers came up with ideas of the sort that, they could boil down to things such as all living things were related, and they had changed over time. So change of species over time. Now, other than what's known in Europe, you read sometimes there are quite a number of other, philosophers elsewhere that came up with these ideas, including here in the Orient. But to restrict it to these 2, just to note that this is the background for Darwin. I mean, at the time when Darwin was trying to formulate the ideas, there were these ideas before him. Now, just before Darwin was born in the early 19th century, Lamarck actually had ideas of the sort about the gradual change of species, that species actually change. So I will talk about Lamarck's gradualism later on. So gradualism is the idea that if species change, then they change very slowly over a long period of time. They couldn't just jump from one form to another. So there has to be some idea there about how this could happen. Now, the main problem was that you needed an idea that will actually fit the idea of evolution of species and also evolution of the Earth. And you needed this time frame for that particular sort of change. Now, the change over time that people thought of at that time to explain fossils was catastrophism. To explain how fossils appear and how different sort of fossils are there, why from one layer in the rocks to another layer you find drastic changes between organisms. So they suggested that every now and then some catastrophe hits the Earth, and then it wipes out all or most of the organisms, and then you have a new set of organisms appearing. So geological catastrophes occurred according to this. Now, in order to explain how or in order to fit in catastrophes within the Earth's history, then they have to think about the Earth being very old, because before that, people thought of the Earth as being a few thousand years old. So in order to explain all these different stages or different sort of forms that were appearing in the fossils, they suggested that maybe the Earth was maybe more than 70,000 years. Now, 70,000 years for that time was quite a lot. You know, it was a revolution to think of the Earth as being that old. Now, creationists had to put some explanation to this when people could show that, well, there had to be some catastrophic explanation. Then creationists would suggest then that maybe there were so many catastrophes followed by so many creations. So a catastrophe followed by a creation, so something like 50 to 100 successive creations according to the creationists. Now, the idea of gradualism conflicts with the idea of catastrophism. And this actually was a major breakthrough in geology, to think about the change in the Earth occurring gradually. And that's actually, it's not the gradualism that matters here, it's that how we could explain recent, or what we discover today in the geology. How we could explain this by maybe catastrophes, like some people say. And then some people suggested that we don't have to really imagine different things happening so many thousands of years ago. All we have to understand are processes that we see today. And this is the idea of uniformitarianism, which says that geological events that we see, that we study, we see in the rocks, we see in mountains, in the valleys, in the desert, and everywhere. We find these phenomena, we could explain them by processes that we can actually see today. These little forces that happen today are the same forces that were happening at that time, or events in the past occurred the same way they were happening at that time. So, if we see things such as, for example, rock formation of this sort, and then we try to explain these. If we want to explain them in the catastrophes, it will be difficult to explain them, but it will be easier, in effect, despite the fact that people didn't realize this. But we can actually explain them by small processes that we see today, erosion and deposition. We experience every winter, and we might be experiencing it over the next couple of weeks. We get enormous rains, and then we get floods, and then we get mud all over the place. And then if we don't clean them, they will remain there. Now, if this happens in various places, then more layers of mud, more layers of sediments, and then you get accumulation of this sort. So we can actually explain this by the little forces that are happening all the time. Rivers keep, for example, depositing sediments. Like in the desert, you find wind carrying dust and sand, and then you get various sort of sand formations there. Then over time, you get more and more and more and more layers. And then if you consider this within a time scale of millions of years, then we could understand how these could actually turn into something else. First, they accumulate. Next thing, they might actually turn into, become lithified or be turned into rock. Now, a simple process that we observe quite a lot, and that's really the formation of these forms in, like in Jaita. Now, these enormous things sometimes, like maybe 1 meter or 2 meters, whatever, these actually are formed by a small process that we can observe. We can sit there and observe that process happening. A drop falls from one form, and then it deposits something in another form. And so you get one drop by drop by drop. And it's said that maybe 1 meter of these structures will take something like 8,000 years. Now, this is just a small scale when you consider the formation of mountains and valleys and even the continents as such. And so, whatever it is, we're not talking about thousands of years, we're talking about something that takes much longer, so maybe millions of years. And so, in order to considering that this process is very slow and it produces very small effects, then for something so small to translate eventually into something enormous, then that will have to take a very long time. And so the gradual process will mean that the Earth is very old. Now, this is in geology, but then someone came to incorporate this idea into the biological species. Now, Lamarck is known for the wrong things. He's not known really for something positive, like the fact that first he talked about change in species. The other thing is that the change that occurred in species was actually changes that are very slow and gradual. And he incorporated the concept of uniformitarianism. Now, we cannot necessarily see change in organisms, or at the time of Lamarck, but now we can see change in organisms. We can see change in DNA. We can see changes in various organisms. And they're very small changes, but over a long time, then these would translate into some big differences. And so Lamarck was the first one to incorporate this idea of the gradual change in species. Now, the notion of branching is also important because at that time when people were struggling to classify organisms, they could come up with something as simple as this linear classification of organisms from the imperfect organism into the most perfect. Now, the organisms that we have even today, sometimes people use the term lower organism, higher organism, lower plants, higher plants. So the idea was this hierarchy of organisms, talking from primitive or imperfect, the ones that are not so sophisticated, eventually into something more sophisticated, such as humans. So humans are considered to be more perfect than other organisms. And then in Christianity actually took this further, and they talked about something even more perfect than this, like angels, archangels, and eventually God, that the most perfect. Anyway, this notion of linearity, that's called the scala natura, or scale of nature, the great chain of being, is replaced by a new idea by Darwin and by evolution, the idea of branching. It's like any family tree. You have a grandfather, and then you have descendants from the grandfather. And so we start from some ancestral organism, and then it branches into all sorts of species that one would be able to trace back to some common ancestor. Now, an important aspect there that this will imply is that when people classified organisms in the past, they classified them on the basis of some similarities. And people classified these things quite a lot at that time. And they had groupings that still exist today. We still adopt some of these groupings. Some of these groupings have actually changed. But on the whole, similarity wasn't more for them than just similarity. But for Darwinism, it meant relationship. The reason why organisms are similar is because they're related. If two organisms are most similar, that means they are most related. They have a common ancestor. And so the idea of branching would say that there it is. The fact that they're similar, it means they're descended from common ancestors. And then one would look at the situation of similarity in a different way. So that's one quote by Darwin, that the only cause of similarity in the individuals we know of is relationship. And that actually is an important aspect there. Now, this is one of the scribblings that Darwin had, trying to relate some groups of organisms. Now, the fourth postulate there, which is particularly Darwinian, Darwin and Wallace, and the idea of selection, natural selection, was influenced by an economist. He wasn't actually a biologist, Thomas Malthus. Some of you probably have heard of him. Now, the idea of Malthus is simply that, he studied human populations, and he wrote an essay on the principle of population. He meant human population. The idea is that populations grow in a geometric manner, but we sometimes call exponential, different thing. But anyway, it grows in this form, graphically, and then resources associated with these populations will grow linearly. That means at some point, the population will grow beyond the resources available. And so you get a point there where there will be conflict, a point of crisis, where the population goes beyond what the resources could provide for it. And he was able to observe this for various human populations. So as populations increase in this way, as they reach the point of conflict there, or the point of crisis, then you have all sorts of problems such as food shortages, famine, diseases, war, and so on. And this is something that Darwin thought of as something that we could adopt that will apply to all sorts of populations, not necessarily humans. All sorts of population might actually come to a point where the resources will become scarce relative to the size of the population. It was also influenced by successes in artificial selection. Now, some of the familiar things we have in life today, like all different sort of breeds of dogs, These actually are done by selective breeding. You select particular traits that people prefer, and then people have different preferences, and you have to cater for all sorts of preferences, and so you get all sorts of breeds that appear there. No, these are just a few. We know that there are quite a number of other breeds. There are an enormous number of breeds, and all of these have been produced over human history by selective breeding. They breed some forms and they don't breed other forms, and eventually they accentuate or emphasize certain traits. Now, this has been applied not just for the luxury of owning a pet, but it was actually meant to have dogs that are very fierce and they're good guards, some that are good hunters, they have some good smell very well, and so on. Now, other utilitarian breeding was done for pigeons, for example, and chicken of ours. And so actually Darwin he worked on some of these, on pigeon breeding and chicken breeding, to see how, over time, one could actually produce a change in a species that one might consider to be a sort of adaptation that is produced by selection, and that's artificial selection. Now, quite a number of things that we are familiar with. We eat, some we subsist on, we actually survive on corn and wheat and so on. All of these have been produced by selective breeding. And quite a number of different sort of forms appear from just one species. And it is known that they're one species, but there are various ways of producing, just really bringing out this variation that is there. Now, the natural selection idea demolishes one other aspect of Lamarckian evolution, and that is really that the evolutionary process is goal-oriented. That means it's bound to get somewhere. Like evolution will lead to perfection, which is not necessarily true. The Lamarckian idea is that species do not go extinct, but they become different species, which we know today is not true because some species actually go extinct. And the worst failing by Lamarck was really to think of characteristics that are that we actually get during our lifetime. We might actually have them inherited by our offspring. And so, to take the idea of the evolution of giraffes, for example, how could the giraffe get its long neck? According to Lamarck, we can start with giraffes that don't have long necks, but then, while surviving, they might actually need to stretch their necks to reach the higher branches, and then, by stretching their neck, not too much, a small amount, because Lamarck was very adamant that it was really gradual changes, very small changes. But this small change will be inherited by the offspring, who would also probably need to have their necks stretched even more, and then you will have longer neck in the next generation and so on. But in this case, we're talking about all the giraffes that are there are stretching their neck, and all of them would have their offspring inherit these characteristics. Now, the idea of the inheritance of acquired characteristics is something that even Darwin had a problem with, because it wasn't known much how inheritance occurred. So let's look at the idea of natural selection. Now, according to the idea of natural selection, you have a population of giraffes. Some of them are long-necked, some of them are short-necked. Some of them are slightly longer necked than the other ones. And so it's something that we will find in populations. We have variation. And among this variation, the thing that Darwin didn't know was that the source of this variation is mutation. Today we know mutation at the molecular level happening. And it's mutation that produces this variation. That's why you get different sort of individuals. Now, according to natural selection, out of these giraffes, if the environment favors the ones that have a slightly longer neck, then the longer necked giraffes have a better chance of surviving. And so that means they will have more offspring than the ones that do not have long neck. Now, after many generations, you will see a noticeable change in the size of the neck. After 25 generations, you might actually be able to see that there are now in the population several giraffes that have longer necks than others. And these, if the environment still favors long necks, that means they will still be favored over the others. And so over time, the environment would force a change in the neck of the giraffes. What's happening in this case is that what the giraffes are inheriting, not all giraffes are inheriting long necks. It's only the giraffes that descend from long-necked giraffes that have long necks. And amongst these, you might also have some that have longer necks, and they'll also be favored, and eventually the population will be dominated by long-necked giraffes. Now, this is the idea of natural selection. It wasn't such a difficult idea there, and someone like one of Darwin's proponents, one who actually advocates, who went around talking, Darwin never left his house to talk about any of these ideas. Thomas Huxley was one, and he was really upset that to be so stupid not to have thought of the idea of natural selection. In fact, in principle, it's quite simple. Now, he published things that Darwin didn't publish much about, and that's really the evolution of humans. And he's known for having coined the word Darwinism, and he's also known for having coined the word agnostic. Now, agnostic, maybe some of you are familiar with atheist, but many prefer to call themselves agnostic. That atheist, you're affirmative that God doesn't exist, but agnostic says, I don't know, maybe, but that's not a question that I want to bother with. So that's agnosticism. That means that I don't know whether God exists or whether God has a role in all of this, but one has to explain the ways things happen. Now, since after 1859, Darwin continued to publish on various aspects like he did before, but he also wrote a couple of things about human evolution as well. And he made these psychological relations between man and animals, how they have. I will mention this in a minute. Now, one major gap in Darwin's theory was genetics. He didn't know how inheritance occurred. The same problem that Lamarck had. And so, at the beginning of the 20th century, someone discovered this monk's work, who was actually doing this in a monastery, breeding garden peas and so on. And so, Mendelian genetics was discovered, and in the early part of the 20th century, this provided the single most important contribution to the evolutionary theory. Now, some people thought that maybe discovering how inheritance occurs really would demolish or would really harm Darwinian ideas, but in fact, what happens is that with more knowledge of genetics, the ideas of Darwin are becoming stronger. It's actually consolidated evolutionary thought. But the problem is that the evolution that we talk about today is different from the evolution that Darwin talked about, because now we talk about it with the light of inheritance. We know how things happen. And so during the 30s and 40s, the first part of the 20th century, quite a number of biologists got together, and they got what's known as New Darwinism, or the new synthesis, or the new synthetic theory of evolution. Now, it's meant to explain something. So evolutionary ideas, they should explain something. Otherwise, it will not be a theory. You can just throw it away, and then it will be thrown in the garbage bin. But evolutionary theory explains a lot of things. That one of them is fossils. Now, how could people are close to explaining fossils. Whoever actually wants to demolish evolution sometimes, they cannot explain. But we now explain, evolution explains fossils in the fact that they're just organisms that survived at that time. They were adapted, and then maybe something happened and they became less adapted and they went extinct, and then you had other species coming. And you can see the different forms in the fossils that indicate the gradual change from some organism into different sort of organism. That is, in a way, the evolution of species. In some cases, we might actually put more detail, and so we could put the story, for example, of the evolution of the horse. We know we have enough fossils there to explain this. And we have plenty of fossils to explain human evolution with some problems. But one of the things that sometimes people cannot imagine is to explain how a certain organism evolves into another organism. For example, if one says that this snail species evolved into the other one, maybe you could accept it, maybe you don't accept it, but you will accept it more if you actually look at all those transitional forms. If you look at this transition form, then you will see that that makes sense. actually the change that occurs between each one and the next one is slight. And eventually, over time, you might see a lot of change. Now, one of the things that sometimes could be used to show how much or how evolution occurs is in terms of comparative anatomy. Sorry, can I just... Now, the idea here is that the most related organisms happen to be living next door. Right. Now, if you look at human societies, people who are more related are likely to be the ones living in a neighborhood. Or neighborhoods are usually composed of brothers and sisters, with their families. Cousins, and then maybe distant cousins, and so on. Now, in nature, you'll find that the most related species happen to be also geographically close to each other. And that's a very important notion there that, that shows that you don't have, for example, a species from Lebanon that is related to a species in North America. You have it related to species maybe in Arabia or Africa or in Asia. Now, comparative anatomy shows these sort of similarities. Despite the differences, one would be able to see basic structures there. This, in humans, lizards, cats, whale, whatever, you can see that the basic structures there, the ones that have the same color, are found in all of these organisms. There are some organisms that have vestigial structures, something that will indicate their ancestry. For example, whales are mammals, they're not fish. And the mammals are tetrapods, that they walk on 4 legs. And in the sea, these become useless, and so maybe the front legs will remain, and then the hind legs will disappear. But in some of them, they haven't completely disappeared, or they disappeared as much as they would be necessary to disappear. So you still have some bones there that are that indicate the remnants of the ancestral mammal. Now we see this in snakes. Some snakes have appendages there that indicate that there were legs there, and you can actually see them in certain part of the skeleton. You have, for example, this lizard species from Lebanon. The poor thing, people consider to be a snake, and then they smash it to pieces. Actually, it's a lizard, but it has evolved to have smaller legs, and so you can actually still see traces of the legs there, this vestigial organs. We humans have plenty of vestigial organs. For example, the muscles that move the ears. In other animals, it's an essential thing to be able to move the ear to listen. But in humans, it has become useless, unless you have some ability to move your ear. There, for example, the third molar, which is the wisdom tooth, which gives us problems all the time because it doesn't have a place. Our jaws have shrunk, and this tooth is still there. The hair, for example, and the ability to erect the hair are features that some mammals have to warm up, to keep warm, or sometimes for aggressive encounters. They make themselves look larger. We still have these 2 things there. We have some hair, which is not enough to keep us warm, and we have our hair erecting whenever we get excited, and so that's also another feature. And we have the appendix, as we know, it only gives us problems, and we get surgery to remove it. So these are vestigial organs that are not needed. They're just remnants of the previous existence. And then we have in some people this what's known as Darwin's tubercle, or Darwin's point, which is a point in your ear, if you could find it there. And well, if you don't find it, it doesn't mean that you're not descended from an ape, but it's something that is similar to the tip of the ear that you find in some mammals. We have just such a huge similarity between embryos. The younger the embryo is, the more similar embryos are. Now, it's at some point that they develop into something different, and so the fetus that comes out usually is different, but the earlier stages still contain some of the features that the fish have, the pharyngeal act, which is something that is found in fish. Now, there's no better illustration of how common our systems are with all other organisms than at the molecular level. We have nucleotides, protein, lipids, carbohydrates, DNA, RNA. All of these things are the basic, are important for the basic processes at the cellular level, and that they're found in all organisms. And one could actually take one bit of DNA from one organism and put it in another one, and then it could function there, even in something as distant as a bacterium. you could actually get it to do something there. Now, evolution could explain how adaptations occur. We can see that different mammals, for example, are adapted to different things. One adapted to the desert, ones are adapted to the sea, and so on. And then we have birds that have different beaks that are adapted for different things. Now, one of the problems that people have with evolution is that how we cannot observe evolution happening. Now, actually, you can observe. You cannot observe species emerging because this takes a long time. Not in our lifetime, not in our human history, that you might actually see a new species appearing out of another species. But evolutionary processes are happening all the time. We are aware of, for example, of bacteria becoming more resistant to antibiotics. And that actually is natural selection. The factor is antibiotics. If you use antibiotics too often, then there will be some bacteria that have this natural resistance to. There could only be a few bacteria, but then they will multiply and then they become the dominant bacterial forms. Something similar to happens in insects, where they become resistant to insecticides. And in our age, when there's so much pollution, you also get a number of different sorts of species, like some plants that become adapted to the pollutants, so they become more resistant to pollution. This is an evolutionary process. It doesn't necessarily lead to a new species, but something similar. Now, one of the problems that also people have with the idea of evolution is that how could you have all of this beautiful thing that is not designed by a designer? Now, the concept of design without a designer, this is what evolution is about. Evolution is not about someone sitting there and manipulating how this species evolves and so on. Actually, what's leading to this is that it's a system, like in any physical system, where physical processes eventually lead to certain formation. Now, crystals are formed out of molecules that could just come together and form crystals. That's not somebody moving or moving the molecules or making the crystal. It's just physical processes. Natural laws eventually lead to something. Now, something like the eye, if you look at the stages of evolution of the eye, you can see various stages there that have just come up from certain physical processes that will lead to them. Now, one good example of how things could be designed without the designer is the language. Languages. We know there's so many languages in the world. Some of them have already gone extinct, so to speak, and some of them are on the way to extinction. Maybe natural selection is favoring some languages and not other languages. Languages, you can actually draw family trees for languages, and in the same way like organisms, the most similar languages are the ones found in neighboring geographic areas. And also have the same problems that species have. They're not perfect. They have all sorts of problems with languages. Any language, as you know, is not perfect, and so you get also things that they have actually picked up from other languages. One could, think of language as being something that nobody could think of anybody who has actually designed the language. The language just appeared bit by bit until eventually it takes this form that we know today. Now, obviously, with ideas that might touch on a number of beliefs, then hostility to Darwin would have been expected. And so people depicted him in those days as a monkey because of the implication that the humans might have also evolved. Because he didn't actually talk much about human evolution, but he talked about that man is subject to the same evolutionary processes as any other animal. Now, when you talk about human evolution, at the time of Darwin, you would think that he was bold really to think about human evolution when at that time there was only one non-Homo sapien species, and that's the Neanderthal man. That was the only one known in Europe at the time of Darwin. It's in the 20th century that people learned more and they discovered more. Now, that's what it's supposed to look like. Now, eventually, he said that he expected that light would be thrown on the origin of man in his history. And that's what actually happened, because now we can see we have thousands of fossils from different parts of the world that show human-like skeletons and various traces. And we can connect them now in a number of ways. Now, Homo sapiens is one branch there that is associated with the Neanderthal, but one could go back and trace a history. Now, the latest discoveries in human evolution were, for example, this one from South Africa, which is really producing some problems for people with the model of human evolution. But what's even more controversial is the recent Chinese fossil teeth that were discovered in various parts of China, which indicate that maybe hominins, that's the human-like species, actually evolved separately from African ones, while the accepted idea is that we all eventually go back to the African origin. Now, evolutionary behavior, with a family of bees like this one, they're actually related in terms of DNA. When you look at their DNA relationship there, one would be able to also discover that the ones that are most related in terms of DNA tend also to have something similar in their behavior. Now, when it comes to humans, you might not think that we have many things in common with various animals. We actually have. Take just one simple example there, and just smile. And usually, showing your teeth is something that many animals use aggressively, but in humans, it has evolved something different. Now, a chimpanzee, if a chimpanzee goes and sees another chimpanzee, it bares its teeth. It's like saying to it, don't worry, I'm peaceful, I don't mean any harm, I don't mean any aggressiveness. And so you can actually see this in a variety of, now it's actually a demonstration of pleasure as well. So people smile because they're happy. And so this baboon there is one drawing from Darwin's book, showing its teeth like this, in a way like smiling when somebody scratches its back. So it's really showing how happy it is. Okay, now human behavior, one of the problems that people have with the idea of evolution is that you're making humans just another animal. And that's something that humans don't like. There's a danger that people behave like animals, and so they become aggressive and selfish and all sorts of things that, like some people use the word the law of the jungle will prevail. But actually, one important thing there that that you will see in humans is the way that, for example, they would behave at some levels like any other animal. For example, in terms of mate choice, how males select females and how females select males. You could actually explain it in some simple aspects that you can see in all sorts of animals. To be sexy is something that is found in all sorts of animals that might look sexy as far as the female is concerned, and vice versa. So we can see similar things in humans. We also have the problem of ethics that people are worried about, that, well, evolution could make people unethical. But in fact, at some point, there was misunderstanding of Darwinism. That's what was called social Darwinism. And some people actually tried to accelerate selection by selecting more intelligent humans and really, for example, making the disabled go extinct and these sort of things. Obviously, these are not actually Darwinian ideas. Now, the biological basis for ethics is something that we see not only in humans, in a variety of animals. Like when humans are good to each other, that's not because God said this or because there's some code of ethics that you read here or taught by wise people and so on. It's just because it's survival. It's one aspect of survival there that you will find in humans, you find it in chimpanzees, you find it in lions, you'll find it in lower organs like ants and various insects like bees. And this system works very well, and it leads to the success of the group. And so in that way, humans also have all sorts of behaviors that are not necessarily the result of dictation by God, but because of the need to survive. Now, impacts of evolution theory, well, first thing that evolutionary biology is one important branch. Some people suggest that one has to understand evolutionary biology because nothing will make sense except in the light of evolution, which to a great extent is true. So the effect of Darwin on people's thinking, like there's no biologist that has been responsible for more drastic modifications of the average person's worldview than Charles Darwin, because he changed our view of various things. And we have a number of things that evolution actually eventually refuted, such as the final cause, teleology, that evolution eventually would lead to humans or would lead to better things and so on. It's not necessarily. Typology, where nothing, you can talk about a type and all things similar to it. So these are not necessarily upheld anymore. Now, obviously, the main problem is the conflict with the Christian philosophy, and even nowadays, there are what's known as creation science or intelligent design theories, which would really look at evolution as being the root of all evil. And you can see different things. They're not really evil, but for some of them, it is evil. Now, obviously, this thing touched on our university at some point when someone talked about Darwin as being an example of a good scientist, and people came against him, like George Post, and some people came in his support, like Van Dyke, and there was a conflict at that time, and some students, some faculty resigned, and some students actually were suspended, and so on. So the conflict between evolution and religion is not necessarily a true conflict. In some cases, one cannot deny there are problems there, but some people actually suggest that conflict might actually be due to extremists on both sides that fuel this contradiction between the two. Now, anthropocentrism is something also that would look at humans. I mean, people worry that humans could be considered just one of those animals in nature. But actually, human evolution or knowledge of human evolution would show that we could really be anthropocentric in the sense that humans are unique. There's no other organism or animal in the world that's like this. Now, just to go back to the quote of Darwin's father, you will be a disgrace to yourself and all your family. Eventually, Darwin would die as an agnostic, and he will be buried among, with Britain's great men and women in the Church of England there, in the Westminster Abbey. Now, when Darwin died, some people suggest that he might have actually repented, but Darwin, the evidence showed that he actually remained an agnostic. And when he was buried in Westminster Abbey, you could think that everybody was happy. And one didn't consider that maybe the monkeys were not happy about the idea, not only